In this video, we're going to solve and integrate questions involving transformations of functions and the center of a triangle. We have this function f of x, where k is a constant greater than 1. P is the vertex of the graph of y equal f of x, and q is the vertex of the graph of y equal f of 1 minus x. There are three parts in this question. Parts A and B require us to find the coordinates of P and Q, and part C requires us to determine whether it's possible that the slope of a line is a certain value. Let's go through them one by one. Part A needs us to use the method of completing the square to express the coordinates of P in terms of K. P is the vertex of the graph of y equal f of x. Simply rewrite the equation, then we'll be able to find the answer. You should be familiar with the operation, so we'll skip the detailed steps. You should find that the coordinates of P are k, 2k squared plus 6. Part B requires us to find the coordinates of Q in terms of k. Q is the vertex of the graph of y equal f of 1 minus x, which is a graph that can be transformed from the graph of y equal f of x. We've already found P, the vertex of the graph of f of x, in part A. If we can identify the transformation y equal f of x undergoes to become y equal f of 1 minus x, we can find Q. To better visualize what's going on, let's sketch the graphs. Let's start with y equal f of x first. As the coefficient of x squared of f of x is negative, the graph of the function is opening downwards. And as k is greater than 1, both the x and y coordinates of P are positive numbers, so P lies in quadrant 1. So the graph of y equal f of x would be something like this. Now f of 1 minus x, we can see that it undergoes two transformations. Negative sign suggests a reflection, and the plus 1 is a translation. There are two possible ways for this set of transformations to happen: reflection first and then translation, or the other way around. Let's say the reflection happens first. F of x becomes f of negative x. The x coordinate becomes the negative of the original, and the y coordinate remains unchanged. The graph is reflected with respect to the y-axis, so the vertex of the graph of y equal f of negative x is negative k, 2k squared plus 6. Then transform y equal f of negative x to y equal f of 1 minus x. Plus 1 inside brackets. That means the graph is translated to the left by 1 unit. Is that right? If we do this, the graph is actually representing y equal f of negative bracket x plus 1 bracket. That is f of negative 1 minus x instead of f of 1 minus x. Note that f of 1 minus x is equal to f of negative bracket x minus 1 bracket. We should actually consider the transformation from f of negative x to f of negative bracket x minus 1 bracket, in which case the graph is translated to the right by 1 unit. So the vertex of the graph of y equal f of 1 minus x is negative k plus 1, 2k squared plus 6. We said that there are two ways for this set of transformations to happen. So what if we translate the graph first and then reflect it? Will the result be the same? Translate the graph to the left by 1 unit, we obtain y equal f of 1 plus x. The vertex would be k minus 1, 2k squared plus 6. Then reflect the graph with respect to the y-axis. Change the x to negative x. So the graph becomes y equal f of 1 plus negative x. That is f of 1 minus x. And the vertex would be negative bracket k minus 1 bracket 2k squared plus 6. That is negative k plus 1, 2k squared plus 6. The same result. So the coordinates of Q are negative k plus 1, 2k squared plus 6. Part C. R is the orthocenter of triangle OPQ. Is it possible that the slope of PR is 2? Let's draw triangle OPQ. An orthocenter is the point of intersection of the 3 altitudes of a triangle. So this is R. As PR is an altitude, it is perpendicular to OQ. Assuming that the slope of PR is 2, we may form an equation using this relation. Slope of OQ is equal to -1 over slope of PR. Simplifying it, we get an equation in K. Now what? The next thing we should do is to see if there's an K that satisfies the equation. How do we do that? Right, find the discriminant. The discriminant equals b squared minus 4ac. That is -1 squared minus 4 times 4 times 13. The result is -207, which is smaller than 0. That means the equation has no real roots. Therefore, we can conclude that it's impossible for the slope of PR to be 2. That's it.